Alright, so today we're going to set up analog input and output cards for reading current on an ControlLogix 5000 ControlLogix PLC. So the first thing we have to do is open up RSLinks. We'll go to Communications, Configure Drivers, and we need to add an Ethernet device driver. Alright. Now I've already got mine added here. Once you, if you select add that driver, then you'll get your IP, and you can actually put in the IPs of all your PLC devices that are on your network here. So I've already set this up. So now if we come over here in our RSLinks tree and we hit plus, we can come over and we can see the devices with X's are not currently active on the network, but the ones that are, we can kind of see those. They don't have the X on them. And so we can see here what the device is. We can see it's a 1756, so it's a ControlLogix. And we are, this one particularly is a Logix 5555 PLC. And we it's in slot 0, so remember that the slots count from 0. So this is a 7-slot chassis because it goes from 0 to 6, and we can see like the second card in the rack is actually a IF16, which is our analog input card with 16 inputs, and in slot 3 is the 1756 OF6CI, which is a output. The O stands for output. The 6 indicates there's 6 channels of outputs, and the C indicates that that it is a current device as opposed to a voltage output. So this is a current output card. Again, this is a input card, I for input, and it has 16 input channels. All right, in slot 4 we actually have IP16D. This is an input card. It begins with an I, so it's an input card. There's 16 channels, and it actually labels it right over here for you, DC input. So this is a 24-volt DC input card. In slot 5 we have OB8EI, which is the DC output. Okay, so DC output, and so it begins with an O, which means output. It's got the number 8, which tells you there's 8 channels, and the trailing I before the /A is telling you that it's isolated. So you see here it says isolated, and the E actually means that it's electronic fused. Okay. So that's just, so you can kind of tell by the model number what the things are. You can tell whether they're inputs or outputs. You can tell how many channels they have. And like the trailing I would indicate isolation. So like this one here, again, 6CI for our analog out is also isolated. And in our final slot, which is the 7th slot in the chassis, but remember they number from 0, so this is slot 6, is the OW16, which is a relay. It's a digital card, it's a relay card. So the DC in, DC out, and the relay are all digital. The IF16 and OF6CI are analog cards within this chassis of our current thing. Now we need to know these numbers so that we can add them in our RSLogix. So here's our RSLogix, and I'm going to So here's our RSLogix, and I'm going to create a new project here. So we're going to say new, and you see that it actually pops up the correct controller. So remember, in RS Links, we look at RS Links, it told us that this was a Logix 5555, which has the model number of 1756, which is the chassis, and dash L55. So this is 1756 L55, so we select our controller. We select our revision number, which is the firmware version installed on the PLC, and the only choice that we actually are selectable on here is 16. The other two that are installed on the PC are 19 and 20, but they don't apply to the ControlLogix, which is why they're grayed out. Now we're going to create a name. So we want to give this a name. I'm just going to call this like analog experiment. Okay, and what we're going to do in this is we're going to take and generate DC, or excuse me, generate analog out from 0 to 20 milliamps because we're outputting current, right? It's a current card. And then we're going to feed this as an input into the analog input card. And then we're also going to run it through an ammeter, which of course will be a DMM set up for reading current. And we're going to read the current and then return that back. Okay. We have to select our chassis, so we have to, you know, the 1756, you can get 4, 7, 10, 13, and 17 slot chassis. So we're going to select the 7 slot chassis, which is the chassis that we have. We know that by looking at the PLC, of course, or by looking at the RS links, right? It goes from 0 to 06, so there's 7 slots in there. And then we don't want to store this on the C drive, so I'm going to select the D drive. I'm going to scroll down here, go to the D drive. I've already created a folder here with my name, and in there I actually have a PLC2 analog files, so I'm just going to put that in there. So this is just going to be an experiment, the analog experiment, and I'm going to go ahead and add 1756 ControlLogix here so that we know exactly what this experiment is. Okay, give your names, don't put spaces or special characters in your names, but give them meaningful names. All right, so I say OK there, and now it pops up. I'm not quite sure why the screen didn't quite refresh. I think because of my screen capture program going on here. But I'm going to come over here to IO config now, and I'm going to right-click New Module, and I'm going to add my modules. So again, if we forget what our modules are, we come over here. Now this is our Ethernet module that we're using to actually communicate with the PLC, but we're not going to use it to communicate between 2 different PLCs, which we could. If we had to, we would have to add this module and configure it, but for our uses, we're just downloading programs to it, so we don't need to install or add that module. So any module you're not using, you don't actually have to modify there. So I'm just going to go ahead here and take and add module 2 and module 3, which are my analog modules, because those are all I'm going to use at the moment. So I'm going to add an IF16 module and an OF6CI module, and so those are both analog. So IF16, I'm going to add this. Now this is my analog in, so I'm going to go ahead and name that. Okay, and that's in slot 2. And I'm gonna leave this in float differential mode. Okay, there's some other choices. We could actually put it in integer mode or high speed mode. And I'm going to go ahead and disable keying. The keying is for making sure that you got the exact version if you have to replace a card, something like that. Then we got to figure out what version of card we have in. So I'm just going to take the easy way out for today and disable keying. Alright, so then I select OK, and now I have to go to the configuration. So here's this card. Now this is an analog input card, but if you come over here to the input range, notice that we can feed a voltage into this card, or we can feed a current into this card. And since we're going to be feeding it with our current output card, we have to, of course, choose the current. Alright, now the scaling. Alright, the scaling actually defaulted for configuration for a -10 to +10 because that's what the voltage was showing. So we're going to have to change this. So we're going to go from 0 milliamps. Notice if I flip this back to voltage, you notice how it says voltage over here by the high and low signal. But if I go to milliamp, it changes it to milliamp, but I have to come back and change those between 0 and 20 milliamps. And then the engineering units actually allow us to do scaling. And so we can actually do our scaling right here in this ControlLogix configuration. So you notice there's an offset here. That would be your intercept for your scaling. And then the your high and low would be also reflected in your scaling of your settings here. But what I'm going to do is I'm just going to scale it to my milliamps. So I'm going to put in 0 to 20 milliamps are going to be my 0 and 20 for my high and low engineering units. And so now we could hit on the apply button, but if you click OK, you do apply it, and then you also close the window. So I'm going to go ahead and close that. That was my input card. I'm going to come back to I/O configuration, right click new module, and I'm going to go to analog again, but now I'm going to come down to the O's, and remember I'm looking for OF6CI. If you forget, you can just pop back here to your RS links and look at that, OF6CI. So I've got OF6CI, and I'm going to add that. This is going to be an analog output, and that is in slot 3. I'm going to leave this one on float also, and I'm going to disable keying on this one also. Now when we come into configuration for our output, since this card only does milliamps, we don't have to choose between 0 to 20 or voltages or milliamps. It's already in milliamps. And then I can do my 0 to 20 values here. And then we also have to come over to the limits and set the limits. Okay. So you need to make sure that your limit values are within your range that you're using. We click OK. Now I'm going to come up to Program Tags, and I'm going to name my, I'm going to create some tags. All right, so a couple of things about this software. When you come in here to tags, you first have to go to Edit Tags to create them. And then the other thing is you kind of want to widen this a little bit depending on how long your names are, and also this alias field, because you want to make sure you can read it properly. So you might need to widen these. So just put the mouse right up here to the line between the dividing line there, and you can shrink them or widen them and select that. So I'm going to create a few different items here. I'm going to create the output. So I'm going to have my output. So this is going to be my current out for channel 0. And this then is going to be the alias to channel 0. Now remember, the output is module 3. So notice there's also a few inputs for module 3, but we want to set the output. So you need to make sure 3:0, and then hit the plus sign. Now again, you may have to widen this so you can read it. All right, and we want to select channel 3, output, channel, or card 3, local card 3, output, O for output, channel 0, data. Notice this is now a real value, meaning it's got a decimal point in it, because our configuration was for float. Okay, and current out, channel 0, I hit the thing. Now you can actually, if you know what you need to put in there, you can actually type that in. And you can actually type it in. And so one thing I find very nice is, like, if you need, since you're going to be doing this again, once you type it in, you can copy it, and then you can paste it in there. So now I'm going to have my input current, which is channel 0, and I just reworded that a little bit to just make it obvious. Okay, it wasn't consistent. But remember, input is 2, and it's an I for input. Okay, so I can just paste that in there and select it, or you can take the slow way if you want and use your mouse and scroll down and find it in the thing. But we're doing output is slot 3, the card in slot 3. It's O for output, channel 0 data, and remember these are reals because we set these to be reals. And then what I'm going to do is I'm going to just create a number. This is going to be my number out. And this is just going to be a tag that I can set. And I want this number out to be a real. All right. So remember, numbers or anything that's just a value inside the PLC doesn't have an alias. The alias is for mapping a name to a physical output or input. Okay. And then I'm going to have a number in. Okay. And that I'm going to leave as an integer because I want to kind of demonstrate the difference between reals and integers. So I'm going to leave number in as an integer. So now I'm going to come over here to my program, and I am going to go to the move. Now, if you don't see this, one thing with this software is normally when you start this box, it starts kind of small. So you need to, again, come up here to the dividing line and drag it wider so that you can see all of these. Okay. Now I've dragged it out of place here. Come on. Making it worse. There we go. That's better. All right, so we're going to take our, I'm just going to do a simple move right now. And so what I'm going to do is I'm going to move, and I'm going to move my number out, and I'm going to move it to my current out. And see, by creating a tag, by creating tags here like this under our tags, what we're doing is we gave a description here to our alias. There's also a description field which you can add in here, and this is more description. All right. But by simply creating a tag name, you give a meaning to this actual output, because we know it's channel 0 out of card 3. We know that, but we've given it a name that is more descriptive. Now, this could be, the temperature at the top of the tank, or temperature at the bottom of the tank, or whatever, or actuator at the top of a tank, or pump speed. We can put that in the name, and now the name has meaning. And so then when we go back to our program, then we're going to see both our meaningful name and the physical output right below. So you see both of them when you create tags. So that's the advantage of creating these tags like this. All right, and you see like here the more descripting that I had put in there for the tag, and it shows up above there. So it gives you the ability to do more description, but it's not quite as obvious because it puts it up there in that box. It's not quite as obvious what it was describing. So I'm going to take those out. Descriptions are handy, but I'm going to take it out for now. All right, so the back to the program here then. And so now I'm also going to move, I'm going to create a new rung. So I come over here to the beginning of the rung and say add rung, or I could do a Control-R. And I'm going to add a move over here also. And here I'm going to move channel in, which is my input current, into my num in right there. All right, so now we've created a little program, and now I don't have any contacts in here because I didn't even add my digital cards, right? This is just basically an analog program, just using a simple move. So I'm going to move numeric output to my current out, and then I'm going to move my input current coming in to my to this integer. Remember, num in is actually an integer, right? And so now when we see this, when we run this, so to run this I need to select my PLC. So I'm going to come to the Who active right here, this little network icon, and that's going to connect me through my RS links. All right, so we're going to download this. So we're going to select our PLC, and notice that download is grayed out because we have to actually select the actual device. So I hit plus sign, go to the backplane, expand the backplane, and then select the slot with the actual PLC in it. Now on the ControlLogix PLCs, you can actually put the PLC in a different slot. It doesn't actually have to be in slot 0, but traditionally you'll probably find it there. But now you see that I've selected the PLC itself, and now I can select download. And so I'm going to download this. And depending on your settings here, it'll go into remote program mode because I downloaded it remotely, and I need to go back to run mode. So you come over here, if you see the cyan color up here, click on that, select run mode, say yes, and now it's in run mode. All right, and so notice that we're outputting 0 and 0 here, but the input is not quite 0 because there's some noise in the system. But now if I flip over to tags and I go to my number out and I put in 20, then you can see that the current in is also 20. But notice the number in. This is what I wanted to show you. This is a decimal. It's an integer value, so there's no decimal point showing here. The style is decimal. We could change it to octal, or we could change it to binary and look at it as a bunch of ones and zeros. Or we could change it to hex or decimal, but the data type is an integer, so there's no decimal point for the numeric in value. But the numeric out, since it's a tag, I can change it, so I can make this like 15 milliamps. Or I can make it 5 milliamps. And you can see that I'm outputting 5, so that's what I'm moving to my output. But remember, we're feeding in. I'll show you the circuit here in a little bit, but we've got the input current is being fed by the output current. So they're just basically wired together. So whatever I'm outputting is what I'm reading in. All right. But again, you can see there's some a little bit of flex in there, or noise in the system here. So its input is not exactly 5.0, but just got some extra noise in the system. All right, so I'm going to go ahead and go offline here. And what I want to do is I'm going to modify the program here. So when I do a move, when I'm moving the output out, instead of simply moving the output out, what I want to do is move, I want to connect it to the selector switch. Okay, so I do need my DC input card now. So I'm going to come up to IO config, new module, digital, okay, and IB16 is my DC input card. Okay, if you forget that, again, we can look at RS links and IF16, IB16. There it is. IB16 it's IB16D. It's got diagnostic inputs on it also. So that's the card I have. That's why we need to make sure we look at RS links so we can select that. And so I'm going to add this, and this is just DC input, and this is in slot 4. And I'm going to disable my keying for simplicity. And there's nothing really to configure here. By default, everything's pretty much enabled, so I'm going to just let that go. But now, under program tags, I've got a four position selector switch. So I have my second selector switch, SS2_4, and that is local, slot 4, it's an input, data dot, and that is actually bit 4. So what I'm going to do is I'm going to copy everything but the last 4 there, and then I'm going to put in here SS2_5 and SS2_6, and I'm just going to paste these in here. Let's see, that should be a 5, and that should be a 6. And then S2_7 would be the 7. So these are my 4 selector positions. And so what I'm going to do is I'm going to take these 4 positions, our selector switches, and so what I'm going to do is I'm going to take this move here, instead of simply moving that, I'm going to modify it. I'm just going to output a fixed number. So if the selector switch is in the first position, I'm going to output 4, which is going to be 4 milliamps. And so I need a bit here. So if SS2_4 is pressed, then I'm going to output 4 milliamps. And then I'm going to come over here, I'm going to do a Control-C while I've got the number of the rung is highlighted. I'm going to Control-C, Control-V, and I'm going to paste this 4 times. Okay, so I've pasted, or 3 times. Did I do 4? Let's see, 1, 2, 3, 4. So it's a 4 selector. I want 4 of these. And so this is going to be number 5. And I'm going to output in 5, I'm going to output 8. And this is selector switch 6. And I'm going to output, I don't know, 12 milliamps. And then if we go to the last one, 7, I'm going to output a full 20 milliamps. All right, and so if we look here, then this is my code, so I'm going to download this. So now when I adjust the selector switch, we can actually see that. So I'm going to go ahead and download this. Alright, so here's the PLC. We've got the PLC, we've got a current meter set up. We are coming out of our analog out, our current out. We're coming out of the current out, into the current in, coming out of the current in through our meter, getting 4 milliamps out, and coming through back into our analog output. So we're coming out the positive of the analog out, into the positive of analog in, out of the negative of the analog in, through the meter, and then back into our analog out. All right, so here's the selector switch. So we've got the selector switch here. It's in the lowest position and it's outputting 4 milliamps. As I turn this up, you can see it changing. All right, so as I move the selector switch, you can see it goes to 8 milliamps, 12 milliamps, and 20 milliamps. So, and back down 12, 8, and 4. Okay, so we're controlling our current out by making use of the selector switches, and we can output the current to 4, 8, 12, and 20 milliamps. You can see on the numeric input change as we modify that.